Hello. So here you'll be learning from me to convert nitrile to ketones. What are nitriles? Nitriles meaning having an R group connected to a CN triple bond. And we know that nitrogen is the third most electronegative element in the periodic table, which means this nitrogen will pull electron cloud from everywhere around it, and it will take a delta negative charge, more negative than the rest of them, which means that this carbon will lose a bit of electron density to the nitrogen, and hence will be delta positive. Whenever you see a polarized pi bond, this attracts nucleophile. Nucleophile must have lone pairs of electrons that could be donated. So here, let me just use a Grignard reagent, which is a fantastic nucleophile. A Grignard reagent, general formula is R, M, G, X. So in this case, the R will have the lone pair on the carbon and negatively charged. Now, if I react a nitrile with a Grignard reagent, this is what happens. So the nucleophile R- will attack this carbon of the nitrile group, break the pi bond, push electrons towards the nitrogen, and first it will form this imine anion. Okay? Now suppose I put a prime here to show that this is the initial R. Okay? So the incoming R comes from the Grignard reagent that I added in. This is an intermediate. And recall what we want to do here is to make it into the ketone. So at this step, we would add water. Water will hydrolyze and cleave this CN bond here, and eventually you would have the ketone. So think about it. Imagine you like to have a ketone. There's a methyl group here and a ethyl group here. You have to be careful what kind of nitrile you begin with and what kind of Grignard reagent you begin with. So suppose I have CH3CN. Acetonitrile, that's a very common acetonitrile, very common organic solvent in the chemistry lab. And I give you CH3, CH2, right? MgBr. This is your Grignard reagent. So the negative charge is on this carbon here. CH3, CH2, lone pair on the nitrogen with negative charge. This will attack this carbon of the nitrile group, and in the end, what do you have? The methyl group of the CN will stay. The CN become a CO, and then now the CH2, CH3 joins in. And this is how you form a ketone from a nitrile.